Hello ladies and gentlemen, and welcome to section 10.4 of Mrs. Quinn's geometry class. Today we're going to be talking about multiplication, area, and volume. Alright, let's start with number 1. Let's suppose we have some box and it has dimensions length, width, and height. Let's call them L, W, and I'll put my height right here. So I have length, width, and height. That doesn't really make any sense. So let's make this the height. This is the length. That just makes more sense. Length times width times height. And I'm going to reduce one of these by a factor of 1/2, one by a factor of 1/4, and one by a factor of 3/4. So it doesn't really matter which one. We want to see what the end factor difference is to the volume. So if I take my length, width, and height, and I would have the product of those three things in my volume. Now I'm going to multiply one of them by 1/2, and I'm going to multiply one of them by 1/4, and I'm going to multiply one of them by 3/4. That means that my end volume is reduced by 1/2 times 1/4 times 3/4, which is 3/32, which would remain length, width, and height, which is 3/32 of the volume. So this is the factor that decreases my volume. Let's do another example. I've got 2 bags of rice, and one holds twice as much as the other. If the corresponding dimensions of the 2 bags are to have the same ratio, then the dimension of the larger bag must be how many times larger or as large as the smaller bag. So if I have my dimensions in some cubic form, let's say x to some unit cubed is my volume of the one bag, and let's maybe make that even more specific. Let's call this my units, my total volume. Let's call that cubed, and I'll just leave units off of it entirely. And if my dimensions are being cubed to get twice as much, to find the dimension that each one would have to have, that means that I'm going to take the cube root of both sides, and I end up with the cube root of 2. Now, my question says approximately, so that means this in this form would be the exact form. Let's go ahead and find the approximate, and I get approximately 1.26 times as large. That means that for length, width, and height of one bag, each length, width, and height would be approximately 1.26 times bigger in the large bag than in the small bag. All right, let's get to something a little bit easier. Here we're going to find a multiplication expression to show the area of these 3 shapes. And then we're going to simplify it into a polynomial to actually find the area. So in this one right here, it looks like I have a total length of m plus 1. Hopefully you'll agree with me on that. And I have my length right here, and I have a total width of n plus 1. If I find that area, I'm going to find the area in this whole piece. And I would do that by FOIL. Hopefully you remember first, outer, inner, last. And so when I FOIL the first, I get m times n, which is mn, and that is the area that's right in here of mn. And then when I FOIL, I have m times 1, which is 1m, and that is the area right in here. Then I'm going to FOIL, and I have my inner 1 times n is n, and that would be the area that happens right here. And finally, for my last, I have 1 times 1, which is 1. And this is an area, so it would be units squared. And that last piece, that 1 times 1, hopefully you can find it. That would be the area right here. So you can see how each term in your polynomial corresponds with a piece of area, where this total, when we add it together, equals the total area. Well, I'm not going to highlight on each piece, but if you need me to do that again tomorrow, I can. So we're going to move on to number 4. First of all, my length is going to be x plus y plus 5. And my width is simply going to be x plus y. Now I'm going to do the same thing in FOIL. First, I'm going to take the first term times each term, and I get x squared plus xy plus 5x. And then I'm going to take my last term and multiply it by each term, and I get xy here, y squared, and 5y. Hopefully you remember FOIL from last year in Algebra 1. Now I'm going to combine my like terms. I don't have anything that combines with x squared, but I have 2xy's. So I'm going to write 2xy. I have nothing to combine with 5x, and I have nothing to combine with 5y. And I'm going to put my y squared on the outside, and my units would be units squared. All right, last one. For my length, I would have m plus 11 times my width, which is q plus 9. And now I FOIL. I'm going to get mq plus 9m plus 11q plus 99 units squared. There are no like terms to combine, and I am done. Oops. Sorry you couldn't quite see that. Now I am done. Now let's go on to our last question that we're going to do together. Now we're going to look to find volume. And with volume, we have length times width times height. And let me move this up a little bit. You have, oops, sorry about that, length times width times height. And I've tried to make this pretty obviously a three-dimensional cube, only it's hard to do that two-dimensionally. I've got the outline of this cube right here, and these thinner lines are the inside of the box. And then I've made some extra notes where this line that comes down here has a value of 2, or the width beside it has a value of 2. And so to find my volume, let's first start with the length. I would have x plus 2. My width would be 5z. Oops, 5z. And my height is 8y. Would you agree with that? So let's multiply these two things together, and I get x plus 2 times 40yz, or zy. It really doesn't matter which order we write them in, because 3 times 4 equals 4 times 3. Order really doesn't matter with multiplication. Now I'm going to distribute this through to each term. And in my first term, I'm going to have 40xyz plus 80yz. And finally, I need to remember my units are units cubed. And I kind of ran out of room. All right, that would be the expression for the volume fully simplified. All right, for tomorrow, I would like you to simply find an expression for the area and then simplify it with multiplication. And I will see you tomorrow.